Hello, this is Professor Mike Labasi for Sinclair College, and this is looking at dark web forensics, and this is from my CIS 2808 computer forensics course, and this is topic 10 at the time of this recording, and this is with the CHFI content, which is volume 3, chapter 3. And so dark web forensics itself, there's some concepts here we can look at through this demonstration here that can be used for more than just dark web. Um, But the idea is we need to figure out what dark web is and what it is first, how it's used, and then how you can look for indicators of its use. So um, first off, dark web itself is something called the Tor browser, and you can get that from the torproject.org. And to come across right off the bat, the fact that you have Tor on your system does not immediately mean you're in uh, the dark web doing bad stuff. It's used in a lot of places to help defeat against surveillance. So maybe in countries where people are trying to, sort of show what's going on, maybe from the government, and the government wants to, do a crackdown. It helps block or protect people from surveillance and things like that. So it has a lot of stuff, but the big thing is it's called multi-layer encryption. And so we need to figure out how it works, and just so you have some idea about it. And actually, the thing about it is, it actually began in the 90s. Actually, it's a nonprofit thing, and Tor is the onion router, so it's called onion routing. And actually, this was uh, developed at the Naval Research Laboratory as a way to sort of conceal where you are, um, for military use. So there's some fascinating history behind it here. Definitely look at the Tor.org project site. It's got some great stuff here to look at. But how's it work? We it uses a series of relays, and I have a little sketch diagram, but there's actually probably better ones in the textbook here. Exit, middle and exit relays. Now there's of course multiple than this, but here's really how it looks. So here's our user. Uh, they want to connect to a Tor site. Now, first you need to connect to Tor itself. So you need to have an entry node to get into the Tor system. So just as a hint though here is, uh, sorry. So what we have here is you exit the entry node, and it gets a path to a .onion. That's actually the extension. Now this is also going to be done over HTTPS. There we go. Extend my lab out there. Um, this is going to be done over HTTPS. So this connection still is also going to be private. HTTPS, HTTPS. If it's HTTPS, I'm not going to be bad. But it is a .onion extension, and usually it's a really long, strange pattern, unique. It's not like bad site .onion. There's a few, but most of the time it's this very long thing, and usually you can find those in a lot of places. Pastebin, Reddit. There's places to find where the current onion sites are at. Um, Now, granted, there are different levels of the web here. Um, you have what's the surface web, then you have the deep web, then you have the dark web. So chapter talks about that. I don't want to get into the philosophy of it, but how it really works is this. Um, when you get your path to the site, you basically wrap your traffic. So from entry to node A gets wrapped in that, and then it gets wrapped again. So as it goes through, it sort of unwraps, removes that. It has no idea where it came from, and it just knows where it needs to send it on to. And it's sort of a way to hide the message. And then there's an exit node here. So it's a really probably poor diagram here about it here, but you have the entry, middle, and exit. Now, unless you have some stuff on exit nodes or entry nodes and you can monitor traffic, it's going to be hard to find that. So there's some diagrams here. It's encrypted, it uses .onion. Um, they only be accessed via the Tor web browser itself. So you can't go to these sites with a regular web browser. So, and there's some more with bridge nodes here and relay nodes, and it makes it difficult to censor the usage of Tor also. So, But what we want to do is from a CHFI, from a computer forensics side of the house here, we look for indicators of use. Now, maybe again, maybe Tor was something we need to look for, and of course, we want to find these browser artifacts. So, and there's something about this too is um, even if this is being used, so this user here, there is memory on the system, there's registry entries, and other things we'll look at, like prefetch. There's indicators that can be used, especially if you have a memory of Tor actually open. Now the website will show you the website. The textbook talks about look at open Tor sessions, and you can do that with the netstat, so you'll see that. But I'm going to take a quick demo here and just look at things to look for if the browser was open. And so what we have here is, close that. We have, of course, registry entries. So this is actually Windows 10 here. This is the CHFI Labs, and of course there'll be ways. There are tools that can look for this, identify it. But under Mozilla Firefox for the HKey users, there we'll see Firefox exe. We'll see Tor browser entries. Now, of course, if someone installs Tor browser, can they change that path? Maybe. Um, they're trying to hide themselves here. But you can see that there is some entries here for that, which of course can be, looked at. But really, you want to get the entry itself showing it was there. So that's registry, that's reg entry, registry editor or reg edit. So straight up with that. But this is something called win prefetch. So even if I uninstall it and maybe the registry is cleaned, it's possible that the win prefetch still shows its history. So this is the Windows 10 in the lab, and I launched Tor browser earlier, and I ran a Windows prefetch view, and you can see there are entries for tor.exe with a date timestamp. You can see the date time, and Tor browser exe a few minutes later with that. So there is where it was launched from, the process path. So this can be tied back to, of course, the registry entry to sort of just really show that it was being used. Again, the lab will walk you through this with Win Prefetch. But this tool is great. This idea is if it was uninstalled, there still is traces of it. So that's really, really good thing to keep in mind. And not just that, any app. Now, unless someone really cleans out their system, it's gonna be hard to avoid all traces of its use. So um, Win Prefetch, fantastic thing to look at. And oh, there you go, store Tor right here. So, and in case you want to see what's running, which I think when you do the lab, you will. Here it creates actually connected to the circuit, and I'm on the Tor browser. So you can use it's like a regular browser. I can search for Sinclair, and it's going to use DuckDuckGo as this main search, not Google, of course. And I can actually connect to it. Now, there's something about if you want to use Tor browser for regular use, it gets Tor nodes are blocked a lot of times from specific internal networks, either at, for example, at the college um, or corporate networks, might block it outright. So um, chances are that if a suspect system has Tor, it might be from their own home system. And don't forget about other ways to look for logs, router logs, things like that. But you can see how slow this is taking. Um, so that's the thing about this use here. This is slow. This is going to add a lot of overhead. A lot of encryption, decryption happens along the path, so it's still spinning. But it's finally hit the site, probably get some cache content. Now it's finally loaded, so just keep that in mind. Um, yeah, Tor browser is very slow, but it is still very effective. Now, things we can look at also is if memory acquisition was taken. And so this is a bulk extractor that was ran um, on a memory capture of Tor running. So this is where you want to dig into the artifacts. This is up here, the memory extraction. If a copy of memory was taken before this machine was shut down, its chances are you can use this to look for Tor. So you can browse through this and maybe look at what domains were visited. And so this will help you figure out Mozilla.org, of course, Apache, as you go through this list here, you can also search for certain things. So we see Gmail was visited a lot of times. We can see, yeah, and there's actually a jasoncreek2020 at gmail.com. So maybe we know, oh yeah, from other aspects of our investigation that that is the email of our suspect. Um, so again, there are a lot of metadata sometimes. Maybe I can't see exactly what was put in the message. Maybe I can. Now with the memory capture, you have a lot more power here. And so we can actually go to the emails and we can look for anything from Jason Creek. Here we can sort of get an idea about, let's go full screen here. You can try to extract out possible URLs visited, things that were sent inside the email. And something, of course, the way emails work sometimes too is big one is the JSON. They use JSON for. Um, let's look at search for Jason Creek 2020 gmail.com. So we can search through this and we can look for evidence of actual email use. So here we see, try to find what we think might be an actual match. Here we see jasoncreekemail.com. This is the json.txt, gzip, and so on. So it takes a little bit of legwork, but using sort of following the breadcrumb trails, you can probably find, in this case, here we go. So Google account, welcome to JSON, welcome to Google. So you can see the what's it now? This is just a welcome to Google account. But you can see, I can see what was inside the email because it was in memory in the JSON file. The JSON was in memory at the time. So is it possible to use this to find evidence? Yeah. Um, so a lot of nulls here. A gzip file was sent. So we see more use. There we go. And then we see some information. So we see there Jason Creek talked to this uh, Rian Matthews at gmail.com. Ah, there you go. Transferring 200 million to your account, expiring, expecting the code soon. So it's not very readable and it takes a lot of work, but you can use a memory extraction to help find that. So there's a lot of different ways to do this. Again, this is not just for um, this can be used for almost any kind of app, but memory extraction is definitely a larger thing to look into. But in this lab, you'll walk through and do this with the bulk extractor view. So um, and of course, we can see here again. This talks about prefetch. There's also a way to look at. You can look at the path of the prefetch. Um, I already closed it, but we can look at um, any cache structures left behind. So if they close Tor, there could be some cache stuff. So again, what we're looking at for memory acquisition, what was running, and the actions that occurred. And so you can see with the bulk extractor, that's a fantastic tool to help sort of reconstruct memory dumps. Memory dumps are very powerful, by the way. That means the system is running. We did a memory dump while it was running before we shut it down. Again, looking at the chain of volatility. It's always a tough one to say. Grabbing that memory is definitely at the top of the chain there. Was it open and closed? Was it uninstalled? If we knew it was uninstalled, we can see that. And of course, the browser artifacts, things that were sent back and forth. Even if you can't see exactly what was sent, you might be able to see who they talked to. So metadata is very powerful here. And again, prefetch files are going to be a great way to see what was installed or uninstalled. Of course, uninstallation is going to leave a registry entry too. Um, so it's not a long one here in the demo. Definitely, it's pretty neat running the extraction tool. You'll be able to do that during the lab. Um, Criminals may use Tor browser for dark web use, but again, don't just assume Tor is bad. But the chances are, if you have a memory app, a disk and memory from a suspect machine, and Tor is on there, it definitely should raise some flags. They should look into that. but it's going to help, maintain an enemy and help hide their tracks. So understanding the overview of how Tor works, just good general knowledge, but we can see what tools we can leverage to find artifacts um, uh, of Tor use, and possible dark web use. Another thing too is, again, this right here, the pattern of the URLs. Those could show up somewhere. It could be in server logs, things like that. It depends on it. Dot onion is what you want to look for. That dot onion is going to be a key aspect of this. And again, this is usually over HTTPS, so um, there's still ways to see traffic in and out, but you might not see what the traffic is. Again, that's metadata. It's a very important aspect of this. I just took a really, really quick summary of the slide deck. Look at the chapter, definitely run through the labs, and you'll get an idea about some aspects of dark web forensics. So anyways, that's it. It's a pretty short topic, but thank you for watching.